To understand the logic behind Russia's newest strategic weapon, we have to look at the sky. When an ICBM launches from Russia toward the United States, its trajectory takes it high over the North Pole. But that airspace is heavily monitored by overlapping arcs of U.S. radar networks designed to track and intercept threats. For decades, Moscow has watched the United States pour billions into these defensive shields. From the Russian perspective, every successful American intercept test inches the world closer to a scenario where their primary nuclear deterrent, airborne warheads, could be neutralized. To guarantee a strike can still land, Russian engineers had to look down. By charting a continuous, deep-water route from the Russian Arctic across the Atlantic, they conceived a delivery system operating entirely outside the atmospheric domains where U.S. interceptors function. This concept moved from theoretical white papers into public view in 2015. During a broadcast on Russian state television, a camera over a military official's shoulder captured what appeared to be an accidental glimpse of a classified briefing. That brief frame showed a document detailing an oceanic multi-purpose system, codenamed Status 6. While analysts debated whether the leak was a genuine slip-up or a deliberate signal to Washington, the hardware it described was entirely real. Today, that system carries the official Russian designation 2M39 Poseidon, known to NATO intelligence as Canyon. The Poseidon is frequently mislabeled as a torpedo. It is actually an unmanned underwater vehicle, or UUV. Unlike standard torpedoes, this drone is fully autonomous, intercontinental, powered by its own nuclear reactor, and armed with a nuclear warhead. The engineering here does not rely on science fiction. It synthesizes existing compact nuclear propulsion with deep-water acoustic stealth to solve a specific strategic problem, guaranteeing an uninterceptable retaliatory strike by traveling where radars cannot see. The physical footprint of the Poseidon dictates how it must be deployed. The drone measures roughly 24 meters in length, 2 meters in diameter, and weighs up to 100 metric tons. When you place it next to a standard 533mm heavyweight submarine torpedo, the scale becomes apparent. The Poseidon is nearly 30 times the volume. Standard submarine launch tubes are entirely useless here. Fielding a weapon of this magnitude requires the Russian Navy to construct entirely bespoke, highly expensive naval launch platforms. The primary operational carrier for this system is the Project 09852 Belgorod. Originally laid down as an Oscar II-class nuclear cruise missile submarine, its hull was heavily modified and expanded specifically for this program. Stretching to 184 meters, the Belgorod is the longest submarine in the world. It operates in a dual role, carrying deep-diving midget submarines under its belly for seabed operations, while internally housing a payload of up to 6 Poseidon UUVs. A second dedicated submarine class, the Khabarovsk, is currently under construction, designed from the keel up around the Poseidon weapon system. Intelligence analysts also track a heavily speculated alternative deployment method, known as the Skeef variant. This approach would stage the UUVs inside dormant protective containers placed directly on the seabed, waiting to be activated. We can track the physical footprint of these operations through overhead imagery of Russian naval bases like Severodvinsk. Specialized ice-breaking auxiliary vessels operating out of these facilities, like the academic Alexandrov, have been actively involved in testing the drone's deep-sea retrieval and deployment. The sheer financial cost and engineering effort required to build this dedicated infrastructure reveals Moscow's intent. Poseidon is a central pillar of future Russian naval doctrine, not merely an experimental prototype. Once deployed, the drone faces a severe engineering hurdle. It must transport a 100-ton mass across intercontinental distances without ever surfacing for air or chemical fuel. Traditional UUVs are strictly limited by battery capacity and chemical fuel constraints. Integrating a miniaturized nuclear reactor solves this, providing practically unlimited endurance. The internal architecture relies on a compact liquid metal reactor, generating at least 15 megawatts of power. The reactor creates extreme heat to boil water into pressurized steam, forcing it through a dedicated steam turbine. This rotational energy transfers through a reduction gearing system, directly spinning the rear pump jet propulsor to drive the drone forward. But this design forces a severe tactical compromise. The narrow 2-meter diameter of the hull leaves virtually no physical volume for thick acoustic dampening or heavy radiological shielding around the reactor core. Because of this minimal shielding, the operating reactor likely irradiates the surrounding water, leaving a highly detectable radio-opaque trail in the sea as the drone travels. Furthermore, a direct-drive steam turbine is inherently loud. The mechanical noise of the gears and the pump jet imposes strict limitations on how the weapon can maneuver without immediately alerting enemy hydrophones. While nuclear propulsion grants Poseidon unlimited intercontinental range, its noisy, radioactive footprint demands a highly disciplined operational profile to survive the transit across the ocean. Early media reports often claimed the Poseidon would travel its entire intercontinental route at a blistering 100 knots using a supercavitating bubble. Tactically, this is impossible. Supercavitation requires rocket propulsion and external control surfaces protruding outside the gas bubble to steer. All visual evidence and open-source intelligence confirm the Poseidon uses a standard pump jet, entirely contradicting the supercavitation theory. This data table maps the relationship between UUV transit speed and the detection range of a modern Virginia-class submarine sonar system. The drone's true stealth mechanic relies on extreme speed moderation to actively manage its acoustic signature. If the UUV sustains a high transit speed of 93 kilometers per hour, the turbine and pump jet create enough cavitation noise to be detected from over 40 kilometers away. However, by reducing its speed to a silent running mode of roughly 55 kilometers per hour, that detection radius shrinks drastically, down to a mere 3 kilometers. To evade that remaining 3-kilometer sensor net, the drone moves vertically. Its high-strength titanium alloy hull allows it to dive to extreme operational depths of up to 1,000 meters. At this depth, the drone hides entirely beneath the ocean's thermal layers. These are bands of varying water temperature that refract and trap sonar waves, effectively blinding surface sensors. Traveling close to the seafloor also allows the UUV to exploit bottom bounce acoustics, where the ocean floor absorbs and scatters its already reduced sound profile, further masking its signature from shallow water listening posts. The drone maintains this slow, silent running mode for weeks, inching across the ocean floor until it breaches a tight 2 to 3 kilometer finish range from the target coastline. Only within this terminal window does the attack sequence begin. The reactor spools to maximum output, violently accelerating the drone to its top speed. At a distance of 3 kilometers, a target moving at 100 knots closes the gap in roughly 1 minute. This sudden, extreme acceleration at point-blank range leaves defending anti-submarine warfare units with zero physical time to deploy countermeasures, virtually guaranteeing a successful strike. Early media coverage surrounding the Poseidon fixated on exaggerated claims of a 100-megaton warhead capable of generating radioactive tsunamis to wash away coastal cities. The most analytically sound payload estimate points to a much smaller 2-megaton variable-yield nuclear warhead, but raw explosive power is only part of the threat. Experts theorize the Poseidon may carry a cobalt-salted warhead. This design sacrifices immediate kinetic destruction to maximize long-term radiological area denial. When a nuclear weapon detonates underwater, it triggers a process called neutron activation. The extreme radiation interacts with the salt in the seawater, creating a massive, highly radioactive dome. Ocean currents then carry this contaminated water into target naval bases and coastal infrastructure, rendering them uninhabitable for years. To understand how the Russian military intends to use this weapon, look at its transit time. A standard ICBM reaches the United States from Russia in roughly 40 minutes. A Poseidon UUV takes days or even weeks to complete its journey. A weapon needing weeks to reach its target is tactically useless for a surprise first strike. The conflict would be over long before the drone arrived. This dictates Poseidon's ultimate doctrinal purpose. It is strictly a deep second strike retaliatory weapon system. The Poseidon serves as an ultimate strategic insurance policy for Moscow. It guarantees that even if a rival constructs a flawless atmospheric missile shield, mutual assured destruction will still be delivered, inevitably from the seafloor.